Hi my dear grade 11 students. Okay, today we are going to discuss a question paper having 15 small questions for the grade 11 as according to first part. Okay, question number 1. Write the set of integers between minus 4 and plus 4. Set of integers between minus 4 and plus 4. Okay, you know what integers are. The integers are the negative numbers and positive numbers including zeros on the number line. Then but between minus 4 and plus 4, you know, minus 4 is at the left hand side and plus 4 is at the right hand side. You know, then between minus 4 and plus 4, then are there including minus 4 and plus 4 to the set of integers? Because between, then what is understanding when you hear between? The between. Then if I ask something like between you and me, the number of peoples between you and me, if you ask different question other than this, the number of peoples between you and me, can we include inside to this set? Can we? We cannot. Between you and me, the number of peoples intermediate, then we have to count. Like this, we cannot take minus 4 and plus 4. Then you have to count since the minus 3, right? Then we have indicated the answer minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay? Then they are the integers between minus 4 and plus 4. It's a easy question. Then I explain more. Okay. Then we shall consider the question number 2. Right. The grade 11 first lesson is the number 22/7 rational or irrational? Give reasons. Then what is your opinion? Is it a rational or an irrational number? Right, what do you think? 22/7 is a rational? Then normally we know. 22/7 is a fraction. Then therefore it's a fraction due to the fraction, then it is a rational. Then the irrational numbers can't be written as fraction. Therefore it's not an irrational number. 22/7 is a rational. But you shouldn't complicate between 5 and 22/7. You know that value of 5 is 22/7. The value of 5 is 22/7 approximately. Then if I ask the same question giving 5 instead of 22/7, then answer will be changed. Okay, then we shall consider the next question. I think it will pay you the way. Is the number represented by 5 rational or irrational? Okay, this question I asked. Rational or irrational? 5. The value of 5. 5 is an irrational number, can't be written as a fraction. Because I reminded you again, because 5 approximately only 22/7. Exactly 5 is not 22/7. To easiness of the calculation only, we use 5 as 22/7 as an approximated value. Therefore 5 is an irrational number, can't be written as a fraction. That's why, but approximately can be written as a fraction, that is 22/7. Then you can use 22/7 as a rational, but 5, exactly value of 5 is an irrational number. You must remember this. Okay, we shall consider the next question in this discussion. Question number 4. Oh, it's a set question or set generative method it has given. Okay, Q equal in brackets A over B. However, A over B, then A comma B, the element of integers Z. You must remember, my students, Z. The letter called Z is used for the introduce the set of integers. Remember Z. Then A and B are integers of Z. Integers that is given integers because elements of the Z. Z means integers. The elements of integers. The A and B are elements of integers. The meaning of this part, once again I will repeat. The elements of integers, A and B are elements of integers. You know this symbol used for denote elements. And B in equals 0 because 0 is an integer. But if this B becomes 0, This cannot be written as a fraction because here a over b is a fraction. The previous two question we mentioned something regarding a fraction. The numbers which can be written as fraction can be written as rational numbers, like right here. Okay, then you must have a certain idea with the previous knowledge. Then a over b given as a fraction. At this fraction, a and b are integers, but b is not equal to 0. If this b gets 0, then what will happen? Then a over 0, then something over 0. Then when you divide some number by 0, 5 over 0, infinity, 2 over 0, infinity. My dear students, 10 over 0, infinity. Anything divided by 0 will be infinity. Infinity cannot be written as a rational form. That's why this is given b is unequal to 0 especially. Here, when we consider integers such as 1, 2, 3, 4, 5, 6, or minus 2, 3, minus 5, minus 8, something like, then we cannot consider denominator as a 0. If denominator gets a 0, it will be not a rational number. That's why then a and b are integers and b is equal to 0. Then what is q? Then this question, you see the question? This is the number represented by the set generating method. Which type of numbers are in Q? Which type of numbers are in Q? Okay, once again, this is the number represented by set generating method. You know that method called set generating method. I explained that. Which type of numbers are in Q? I mentioned that earlier. Then a over b is a fraction. The numbers which can be written as fractions are rational. Fractions are rational. Okay, it's a rational. Then you can see rational numbers. Okay, the set of integers, rational numbers. Q is the rational numbers. Okay. Next question. Fraction can be written as two ways. What are they? What are them? Fractions can be written as two ways. What are they? Then according to the answer, when you convert the fractions into decimal form, then you can give your answer, I think. Here, when you see about the fractions, then you cannot say what are the different ways, the two ways. Right? At the answer you can see, one is terminating decimal, right? That's the famous, you know, the decimals, the types of decimals, terminating decimals and recurring decimals. Right? The fractions can be written as two ways, terminating decimals and recurring decimals. Sometimes the decimal number can be, when you divide a fraction, the numerator by the denominator, you will be obtain an answer with a terminating decimal. Then as an example, then if you get 1/4 is the 0.25 students. 1/4 is 0.25 is a terminating decimal. It is limited to 2 decimal place. If you get otherwise 1/8, it will be 0.125. Then you can have the answer by just dividing. It's a terminating decimal. But if you get 1/3, 1/6, something like, then obviously you will have recurring decimals. Then when you know that 1 divided by 3, 1/3, 1/3, 0.3333333, dot dot. You know that, right? Therefore, it's a recurring decimal, right? Then you have to understand that. Then there are two ways: terminating decimals and recurring decimals for the fractions. Right. The non-terminating decimals are coming for the irrational numbers. The irrational numbers especially cannot be written as fraction. Right. Okay. Now these lessons show you what irrational and rational numbers are. Okay. You see. The next question, question number 6. 5/18 convert into decimal. What is the type of decimal? 5/18 convert into decimal. What is the type of decimal? Okay, before telling the type of decimal, my dear students, you must pay your whole attention toward the answer. Then without an answer, we cannot say something, I think that is better. Right, then 5/18. Okay, then just we have to divide 5 by 18. That's why we are going to do 5 by 18. Okay, the division mark 5.0 because 5 is the 5.0. 5.0 divided by 18. 5.0 divided by 18. Okay, we'll see here. 5, especially when you pay your attention towards 5, the number of 18 multiples to 5 is 0. But after having this 0, then you have own right to keep a decimal place over the decimal, above the decimal, and as well as 0. Then it is totally considered as 50. Then now you can say 50 to 18 multiples. 50 to 18 multiples 2. 50 to 18 multiples 2, you know 18 times 2, 36. Right? You don't put decimal places, okay? 36. Now, like by getting a line, then you have to get the remainder. Remainder is 14. Because of this having decimal place over there, then you have to write. You have a right to get 0, more zeros again and again when you continue the decimals, continue the division like this. Then it became 140 with the remainder get as 14. 140. Now you have to consider the number of 18 multiples for the 140. 140. Okay, we'll see. 7. Then 18 times 7. 18 times 7 will be, so what is the answer? 18 times 7. Just can you say 18 times 7? I can't say no. 18 times 7? Just imagine 9 times 7. 9 times 7 is 63. Double it. 126. Wow. It's the answer. Right? My dear students, can you see? When you need 18 times 7, you have to get just 9 times 7 and double it. 126. Then what's the remainder again? 140. Once again 140 has come. Not that 14 has come, but with the decimal place writing, then you can get 0. 140. Once again 7. Because 140 to 7 multiples 18. Then 18 times 7 will be coming back as 126 more and more. Then 7, 7, 7, 7 will be come. Therefore, your answer should be 0.277 dot dot dot. Because it's recurring. The 7 is a recurring number. Therefore, then what is the type of the decimal? I told the answer. Answer is a 0.27 recurring decimal. Then when you complete the answer as a recurring decimal, especially, then if you want to write as a recurring decimal, then you can write 0.27 above the 7, that's dot. You know that it is 0.2 recurring 7. Recurring decimal. It's a recurring decimal. Answer is recurring decimal. Okay. We shall come to the next question, question number 7. State whether the following real numbers as rational numbers or irrational numbers. Rational numbers or irrational numbers. Okay, the first we have to find out the numbers now. Okay, let's see. These are the numbers. These are the numbers. First number, root 5, root 9, root 7.52, sorry, 7.52, root 11. Root 5, root 5, root 9, root 7.52 and root 11. The type of the numbers should be written in front of the each numbers given in the table. Okay. Consider square root 5. Square root 5. Is it rational or irrational? If we just check by means of calculator or division method, the answer of root 5, square root 5, will have a non-terminating decimal. The numbers which are given non-terminating decimals are irrational. Therefore, it's an irrational number. And root 9, you don't use calculator for the root 9 because anybody knows that root 9 is square number, square root of square number is the answer. Then square root 9 is 3. 3 is a rational number. 7.52, can you see as this as a recurring or something? No, it's a terminated one. Therefore, it's a rational number. And root 11. The root 11 is similar with the root 5. The answer is similar with the root 5, right? The similar means not the same, right? Same kind answer, root 5 and root 11. Therefore, square root 11 will have non-terminating decimals as its answer. Therefore, is to a irrational number. Is to a irrational number. Okay, my dear students, then you see the answer to be complete as an irrational number. Okay, let us consider the question number 8. A surd of the form root 72 is defined as entire surd. So, actually we cannot see the question now. Okay, first you read a surd of form root 72 is defined as an entire surd. It's okay, correct. It's an entire form. It's not the simplest form. Okay, first question. Write root 72 in form of a root b. Is a form such as y equal mx plus c, y equal ax square plus bx plus c. This kind of a form. The form is a certain kind. Then a root b, instead of the values a and b, you ought to find out the relevant values for writing this root 72 as a simplest form. Write root 72 in the form a root b. You know, you can see a root b is in its simplest form. To get this in simplest form, the whatever a and b are, then you have to simplify the root 72 as you know. Right. To get this entire surd to its simplest form, then you have to get this 72 aside. Right. We see that simplification. When you divide this 72 by 2, because 2 is the first prime number, then when you divide by this, then 36 is coming. What is 36? 36, especially when we do a calculation with a square root sign, then 36 is a square number. Therefore, that's when we have to stop. 36 is a square number. Therefore, this can be reformed as 36 times 2. Instead of root 72, you can write 36 times 2. 36 times 2. 36 will be given its answer. 6 root 2. 6 root 2. The answer of root 72, 6 root 2. Then obviously we have obtained the form of a root b. Then 6 root 2. A root b, 6 root 2. Can you see? A root b, 6 root 2. Then this is the form where they expected. Right. Okay. Then we have completed the answer for this question. I think there are 2 sub questions in the question number 8. We see the next question. Explain a and b. I think no need to explain further. Anybody can see that. Instead of a, what there is? Instead of a, at the answer you can see 6. Instead of b, at the answer you can see root 2. But b is not root 2. Cancelling root 2, b equal to 2. Therefore, a and b, a will be 6 and b will be 2. Then that's what you have to complete. Here, a equals 6 is a rational number, we know. b equal root 2 is a irrational number. b equal to 2. Then here you must note here, you must keep a note. B equal to 2, especially not to square root 2, by a small fault it has written square root sign over the 2. You must remember, my dear students, I kindly mention that please erase this square root sign to sign above the 2, b equal to 2, because we don't write square root signs because square roots are there. We have to compare the square root to square root, and b equal to 2, b equal to 2, b equal to 2 is a irrational number, is also a rational number. But square root b, I think this is a purpose that happened. Square root b is the root 2 is a irrational number. Square root b is a root 2 is a irrational number. At the answer, according to answer, I think it's better to make square root b the root 2 is a rational number, but b is the 2 also a rational number. Okay, you must remember this. You have to note down that, because I strictly told that I kindly told that, then you have to take this answer, the board method I told it. Okay. Then shall we continue the next question, question number 9. Oh, third question. 7 root 5 plus square root 125 minus root 20, square root 20. Then how to start? Before go to the discussion, then how do I start? When you see the three surds such as root 5, root 125, root 20, then from where should I start? Then what is the smallest part of the three surds given? I think root 5. Root 5. Furthermore, no more simplification at root 5. Therefore, with the root 5, then if we have root 5 terms for the other two surds in its simplest forms, then certainly we will be able to simplify easily. That's what we can expect from the question. Here, then you must think about 5 times. Here, 5 times. Because 125, how many 5 times? How many 5 times for 125? Normally we can say the answer. You just think. 25 times 5. 25 times 5 is 125. Like this. And 25 times 5, which is 25, is a square number. And 20, 5 times 4, or 4 times 5, 4 is a square number. 4 is a square number. Here, then that's how then you have to start, because with respect to this root small root 5, then you have to change and rewrite the numbers given. Okay, first step. Okay, then this is what I told. Instead of root 125, it has written 25 times 5, and instead of root 20, we have written 4 times 5. 4 times 5. Okay, now then we have to simplify further. The next step, then 7 root 5 cannot be simplified. 7 root 5 cannot be simplified. But the next times 5 root 5. 5 root 5 can be taken as answer, because 25 will be supplied its own answer 5, but 5 has an answer root 5, and 4. There's 4. The square root 4 is 2. 2 root 5 is the answer. 2 root 5 is the answer for the 4 times 5. Okay, the next step, 10 root 5. 10 root 5. How do I get 10 root 5? Dear students, pay attention, because positive terms, out of root 5 there are 5. Out of root 5 there are 7. Out of root 5 totally there are positive 12. Positive 12. Out of root 5, 12%. 12 root 5. Here 2 root 5. Out of root 5, 2. Out of root 5, 2. Out of root 5, 12. When you subtract 2 from 12, it's 10 out of root 5. Out of root 5. Then the answer is 10 root 5. Pay attention, okay? That is special. Okay. Now, we have completed the answer. Therefore, we can go for the next question. Question number 10. So, another third question. Root 96 divided by 5 root 3. Root 96 divided by 5 root 3. Then you must know the divisions. Then, but especially dividing square root signs, we have to divide as we know, but having a square root with the numbers. That's how we have to continue this question. You must remember, when we are dividing square root numbers by the square root numbers, then we have to cut as we know, but we have to keep the square root signs above the numbers. Like, okay, we see the first step, the question itself. Right, but a small change has given. Instead of this division signs, then you can see 96 divided by 5 root 3. 96 divided by 5 root 3. Then we have used the normal division sign 5 root 3. It is the root 96 over 5 root 3. Root 96 over 5 root 3. Okay, what do we do the next step? Then, as I mentioned, then we have to divide between root 3 and root 96. Root 3 and root 96. Then Shall we see that? Root 3 and root 96. Root 3 to 1 is square root 1. Square root 1 is 1. Therefore, no need to mention. If you're okay, then you can mention. The root 96 to 3 multiples, you can see 32, because 9 to 3, 62. But especially you must remember, you have to keep the square root sign above the number, because it's a surds division or a small division or simple divisions. Then you have to get the square root sign. Here, root 32 divided by 5. Root 32 divided by 5. Furthermore, can we simplify? Why not? Of course, we have to simplify. Right? Then, root 32. Root 32 can be written in simplest form. Root 32 more, if you think, it is 16 times 2. That's how. 16 times 2. Then 16 times 2 square root divided by 5. Then your answer, then you can have the answer for the square root 16 easily 4, but no for the 2. Therefore, root 2. Then your answer will be 4 root 2 over 5. 4 root 2 over 5. That this is the complete answer, what they expect at the exam. Then as far as possible, you have to simplify. Then you cannot give up the steps or anything with the questions. Then you have to do with the process that has taught by your teachers for you. Right? Okay. Today we are going to continue the next session of this month. So we are going to discuss the remaining questions of the paper we have already given. Oh, special question. Indices. Negative index and as well as a positive index and 2 fractions inside the brackets. Right? I think no need to read the question. You can see the question. Then how can I start the question? Because having such a negative index, then you can see here, negative index, then immediately you have to do a change for the negativeness. We have to remove of this negative sign. As a result of that, then you have to get the reciprocal of that, Then that's how, then you have to get your start somehow. After that, we have to consider the other steps. Okay. Fine. Okay. You see. Yes. Same problem once again written. This is start. Can you see? Oh, without writing that negative part, we have written 16 or 25 power 3 second with the power 3 second. It doesn't change. This doesn't change, but what has happened? Minus 3 over 2 has become to 3 over 2. But as a result of that, you can see what has happened. 9 over 100 has changed to 100 over 9. You must remember, my dear student, you must pay your attention to the exam. This is essential. When you change a negative sign of an index, you can change negative as positive, just you can give up the negative sign. But as a result of that, you must remember, you have to get the reciprocal of the base. 9 over 100 should be written as 100 over 9. Can you remember? Right, that's what then you have to first do. Right, okay. So continue to the next step. Oh, what has given? Then 3 second, or otherwise 3 over 2 was the powers and 3 over 2 was the indices. Right, according to their indices, then inside numbers can be rewritten. Here 100 over 9. 100 is square number, 9 is a square number. Then 100 can be written as 10 to the power 2. 9 can be written as 3 to the power 2. Then through the mouse pointer I will show you. Then 100 can be written as 10 to the power 2. 9 can be written as 3 to the power 2. Here 16, 4 to the power 2. 25, 5 to the power 2. Then power 2, power 2, power 2, power 2. Can you see? Right? That's why. Because of that 3 over 2, 3 over 2 only we got that power 2, power 2, power 2. So something to the power 2. Then the power 2 will be common number, then can be taken out from the bracket as a power, but as a power. Okay, see. Yes, of course, we have done the what we expressed earlier. Here, the power has been taken as a power, as a factor, power factor, then 2 and 3 over 2, and 2, 3 over 2. Then, what's your expectation? Now, you know, right? Power 2 to power 2, or 2 to 2 can be cancelled, and 2 to 2 can be cancelled. And what will remain? 10 over 3 to the power 3 and 4 over 5 to the power 3. Pay attention. That is easy. When you write down, when you see this again and again, then you can understand, right? Okay, the next step, 2 to 2 and 2 to 2. And what we remain with? 10 over 3 to the power 3 and 4 over 5 to the power 3. Yes, you can see the previous steps and check, right? Pay attention. Okay. And what is coming? 10 to the power 3, of course, 10 to the power 3 is 10 times 10 times 10. 4 to the power 3 is 4 times 4 times 4. 3 to the power 3, 3 times 3 times 3. Because this power 3 is, remember, effective for 10 and 3 both. Here power 3 also, 4 and 5. That's why we have written 3 tens, 3 threes, 3 fours and 3 fives by expanding, because you know how to expand. But the thing is, you don't pay attention when you expand in such kind of a fraction. Normally, a lot of students are writing 10 times 10 times 10, but not 3 times 3 times 3 at the denominator. Only 3. They are writing only 3. That's why they are getting drawn. Then that's what we are teaching, right? My dear students, you have to take what we are teaching like this. Then you have to understand and you have to pass your examination. That is your target at the future. Okay, now that's 8 times 64. How do we get this 8? Because you know, by cutting 5 and 5 and 5, then we can obtain 10, 10, 2, 2, 2, 2. Then that's how 2 times 2, 4. 4 times 2, 8, and 64. 4 times 4, 4, 4 times 4, 16, 16 times 4, 64, and 3 times 3 times 3, 27. 5, all the 5 numbers have been cut. And what is the final answer? 8 times 64. 8 times 64 is 512 over 27. This is the answer. This will be enough because this is an index question. Oh no, how wonder. We have given another alternate method, method 2. I think this is much easy other than the previous step. Okay, we'll see the another method to do the same question. If there's something like this, in our lessons, we are giving those things for our loving students, because we are doing everything for teaching. That's what we are doing always. Okay, you see the method 2. I think this is very easy other than the previous question, but previous method also okay. It's a genuine method. This also another method. Right, same question. Same question. The same thing as previously mentioned. You can see, because no doubt minus has changed and reciprocal as a result of that. Oh, that's the difference comparing the earlier simplification and now. You can see what has happened. Now the student has seen that 3 over 2, 3 over 2. You must see that 3 over 2 is a common power. That's what we have written. 3 over 2 is a common power. Then we have written that 3 over 2 is a common, getting 100 over 9 and 16 over 25 together. Can you see? Right. Again, we are going to follow these steps. Yes, we have stick at that step. Yes, between 25 and 100 we can cut. You know. Yes, there are 4 25 multiples. But unfortunately, we cannot cut between 9 and 16. Then we have to satisfy with what we have. Yes, it's 64 over 9. But power 3 over 2 will be remain as given. Easy. Very easy. 64 over 9. And next time, as we previously mentioned, then you have to get the 64 as 8 to the power 2 and 9 as 3 to the power 2. That's how then we have written 8 over 3 to the power 2 at once. You must remember, okay, you have a certain idea about that. Then easily you have to finally cut 2 to 2. And what is your answer? 8 to the power 3, 512, and 3 to the power 3 will be 27. We haven't shown that steps 2 to 2 cut, but no need, I think, because we have done same question. The 8 to the power 3 is 512 because 8 to the power 3, 8 times 8 times 8, 512, and 3 to the power 3, 3 times 3 times 3, 27. Right? This answer is the same as the previous. Okay. Question number 12. Simplify and express using positive indices. Using positive indices, they expect their answer, our answer, in positive form of the indices. Okay, then how can I start this question, because there are too many exercises? Or do you feel something like, okay, we'll see. One by one, we have to get that steps, because minus 2, the power minus 2 will be remain. Here, what you know about the cubic root? I shall take your whole attention towards the cubic root, my dear students. My dear students, take this cubic root, because this is cubic root. The cubic root we can write as a power. If there is cubic root, it is 1/3. If there are fourth root, it is 1/4. Fifth root, it is 1/5. Normally we can use this as 1/3, having this minus 2 as well and inside numbers. Right? You don't get upset with the question. Then you have to do what I asked with the question. What you can, I think, what you can is this. Then instead of cubic root, then you just get a first step. You don't have your answer. You don't have your answer. Before the answer, you get the first step, what you can, with what you can. Right? Here, this is what I mentioned. That is 27 x to the power 3 and cubic, instead of cubic root, we can write 1/3 power into minus 2 power. Into minus 2 power. Right? Having the minus 2, you don't remember the minus 2. Finally, we can change the positive as a positive index. Okay. Until that, we have to do something. 27, 3 to the power 3. You know that? X to the power 3 and 1/3. What will I ask from my heart? Because of this 1/3 power, normally any student can write this 3x to the power 3. This 3 to the power 3, x to the power 3, 3x to the power 3, and 3 will be cancelled out. Then you can see that's what happened. 3 to the 3 and 3 can be cut, and 1 time minus 2. 1 time minus 2, minus 2. 1 times minus 2, minus 2, 3x to the power minus 2. But remember, this minus 2 is minus 2 is on to x and 3 as well. Both number, 3x. 3 and x. 3 to the power minus 2 and x to the power minus 2 as well. Therefore, when you get the reciprocal, to change this negative sign, then you have to write 1 over whole 3x to the power 2. Because some students are getting only 3 over x to the power 2. It's wrong. It's to be the answer. No use of writing like this, those things. Then you have to understand, you have to remember what we are pointing out. They are always here. It is 1 over 3x to the power 2. It's 1 over 9x squared. 1 over 9x squared, because you know it's effective the power 2 for the both numbers 3 to the power 2 is 9, and x to the power 2, 1 over 9x to the power 2. Okay, pay attention, because using positive indices, we have of course used positive index, then therefore it's the answer 1 over 9x squared. Okay, we shall go for the next question. Question number 13. Or bracket removation and surd simplification, but I can say binomial expressions simplification. Right? Binomial removation. You see, 2 plus root 3 minus root 6, such as binomial expressions, because when you have a question like a plus b, a minus b, or a minus 2b, something like, right? Then at this time, then what are you doing normally? You have to one by one remove the brackets. From the first two guys at the bracket, you have to remove the next bracket in front. Now what is the first guy? 2. The next guy, root 3. Then first person 2. The second person, root 3. So first number 2, second number root 3. By those things, then you have to remove this bracket. You have to attack. Okay. Now, you have to start your question. The same question we have to rewrite. And by the first person 2, you have to get your target root 2 minus root 6. From the next person plus root 3 plus root 3, especially plus root 3, you have to get the same target. The first person as well as the next persons are getting their own targets towards the next bracket. Root 2 minus root 6, root 2 minus root 6. Okay, can you see? Here, now according to knowledge that you have to use and multiply and remove the brackets. Okay, one by one we shall continue. 2 times root 2, 2 root 2. You know, 2 times root 6, 2 root 6. Root 3 times root 2, root 3 times root 2, root 3 times root 2, root 6. Because unlike that, when you multiply unlike that, root 3 times root 2, root 6, root 5 times root 3, root 15. Oh, if you want, then you better write this note. Like surds and unlike surds. Like surds means, my students, root 3 times root 3, 3. Root 5 times root 5, 5. Root 7 times root 7, 7. Root 8 times root 8, 8. But root 3 times root 2, root 6. Root 4 times root 3, root 12. Right? You must remember. Right? Root 5 times root 3, root 15. They are unlike surds. Then according to that simplification knowledge, then root 3 times root 2 becoming root 6. And once again, root 3 times root 6, root 18. You know, root 18. Furthermore, there are more simplification, I think. With the like surd simplification 2 root 2, but consider root 2 root 2 root 2, there are no like terms, but root 6 between root 6, you can simplify more. Minus 2 root 6 and plus root 6. You can see minus 2 root 6 and plus root 6. Then what's the answer? Negative 2 root 6, positive root 6. So negative root 6. And here negative root 18. But I can't satisfy with what we have the root 18. Root 18 can be reformed as 9 times 2. Right? Then 9 times 2, instead of 9, we can have an answer like 3. 3 root 2 will become, right? You see, yes, 2 root 2 minus root 6, 3 root 2 is the answer. This is the final answer, because furthermore, there are no any like terms, because root 2, root 6, yes, minus 3 root 2. I didn't see. Minus 3 root 2. Right? When you see that, immediately you have to do further steps. Right? 2 root 2 minus 3 root 2. Like positive 2 root 2, negative 3 root 2. What's your answer? Minus root 2. Minus root 2 and minus root 6. Okay, further there is. Because minus is common. Then I don't like to keep this answer like this, then it's okay for some students, okay. But furthermore, then you can have a minus sign as a factor. Minus and root 6 plus root 6, because when you have obtained minus sign as a factor, the minus will be plus and your answer will be root 6 plus root 2 plus root 6 multiplied by minus with the bracket. Okay, this is your final answer. Okay, that's how you have to simplify. Okay, question number 14. Find the length of BC in the triangle ABC. Where's triangle ABC? I don't see. Okay, we'll see. This is a triangle ABC. According to the triangle ABC, then we have to find the length of BC. They have provided some two data. AB length 2 centimeters and AC length 16 centimeters. Find the length of BC in the triangle ABC, the BC. Okay, when I see such kind of a right angle triangle, no need to say anything, because there's behind, I think, Pythagoras. You had to use Pythagoras relationship to obtain the other length, remaining length, especially when we have this kind of right angle triangle. You know that. Then you learn that from since grade 9. Right? Therefore, then you have to take the Pythagoras relationship. You know how Pythagoras relationship is used. Then you have to square the two adjacent sides, the square sign, and with the other hypotenuse square outside the equal. Okay, then that's what I am going to do to get the length BC. Yes, you see, BC square and 2 square equals 16 square. BC square plus 2 square equals 16 square. You can see BC square plus 4 equal to 16 square. 16 square, 256. 16 square, you know, 16 times 16 or 256. Then you have to simplify BC until you get the BC. Then plus 4 should be taken to the side. Then 252 has been obtained, because when you take plus 4 to the side, we have exact at once simplified BC square equal to 252, because we have obtained plus 4 as minus 4. They have simplified together 252. But when you're having that square root of 252, because you know that square is taken to the side, square root will become, before that, then we have to divide until we have biggest square number to get the answer. Therefore, then we have divided 252 by 2, 2 multiples, then 176 when you divide by 2, 88 when we divide by 2, 44 divided by 2, 22, and again 11. Then what is the possible, largest possible square number that can be happen? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. The 16 is the largest possible square number for the division. Then 16 times 22 will be come inside the square root sign. That's what 16 times 22. Then 16 knows its answer as 4, and 4 root 22 is the answer. 4 root 22 centimeters is the answer. The length of BC is 4 root 22. Okay, we shall continue the last question of this discussion. Okay. Oh no. Taking root 3 as 1.732, find the value of 5 over root 300, correct to 2 decimal places. Taking root 3 as 1.732, they have given the actual answer, I think. Root 3, 1.732. Find the value of 5 over root 300, correct to 2 decimal places. But given root 3, it's unfair. That has given root 300. Then until what they have submitted, obtaining, then you have to simplify the first. Otherwise, you can substitute that 1.732, my dear students. Right? Then somehow you get your first step. That's what we need. First step with what you can. The 5 over root 300. Okay, you say 5 over root 300. It's 5 over 100 times c. Anybody can do this. 300 is the 100 times 3. Having a square root, then you must have a square number. The largest ever possible square number is 100 here. 100 times 3. 100 times 3 is square root. Now you can have the further answer. 5 over 10 root 3. Because 100, square root 100 is a 10, 10 root 3, 5 over 10 root 3. Furthermore, 5 and 10 can be cut, and root 3 has been obtained already. But wait. Then we have to do the next step. You don't go for the answer, my students. You get the next step. That will pay for your answer. Yes, it has cut and more. Something has done. Yes, we have to rationalize the denominator. Otherwise, until that you cannot do the substitution. You must remember there's a reason behind that, right? Then you have to rationalize the denominator. Otherwise, you cannot substitute. If you substitute root 3 as 1.732, then it will be a trouble step, because you have to divide 1 by such a bigger decimal number is difficult. That's why we have to immediate rationalize with what we have as the answer. Then to rationalize the part, then you have to multiply both numerator and denominator by root 3 still. Right, then 1 times root 3, everybody knows, root 3, and 2 times root 3 times root 3. I mentioned that, I gave you a note, root 3 times root 3, 3. Then root 3 over 6 has obtained until root 3 over 6, yes. Continuing, root 3 over 6, you can see root 3 over 2 times 3, 2 times 3 is 6, then root 3 over 6, root 3. Now we can use the value that has given, because instead of root 3, we have to use 1.732. Then we have to substitute 1.732 over 6. Okay, now one by one you have to divide. or 0.288. Okay, just say, then you have to divide the number. When you divide 1.732 1 by 1 to 6 multiple 0, then to the pointer, I will show you 1 to 6 multiples 0 and 17 to 6 multiples to 12, 5 remaining, 53 to 6 multiples 8, 48, 5 remaining, 52 to 8, and more numbers will become. Then you have to enough to answer correct to 2 decimal places. That's why we have limited that answer. Then what is your answer finally? With the 2 decimal places, you have to round off the number 0.288. 0.288. When you round off the last digit, then you have to remove the last digit and add in 1 with the rounding off method. Then your answer will be 0.29. 0.29. Okay, that's how then you have to obtain this kind of a question. Especially you must remember again, when you have obtained a question like this, then we have to start with what you can, and get the first step, you go for the next step, and you will be able to get your answer as you expect. That's what we have to say at this discussion. Okay, we have come to end by discussing from first question to 15 questions, right? Now we are going to wind up the first session, the January session of this grade 11 part. Then we are hoping to continue the next session from the next month. Okay, until that, we have to say bye bye, my dear student. Goodbye.